If we can figure out gravity, we're done with physics. We're completely done with physics. We know how this universe works. That's how important figuring gravity out is. And this is the rundown. This is my line of thinking, okay? And again, stop me if you believe that it's too choppy, if the video is too choppy. Okay, here it goes. This is my line of thinking. I'm saying we have to ask this question: what causes gravity? Okay. Once we answer this question, we're done with physics. We know all there is to know about how the universe works. Because essentially, we have the grand unified theory, or the theory of everything, because we're uniting light with gravity, gravity with light, or electromagnetism, right? And if we stick to gravity, we only have two possibilities. It's only push or pull. Those are the only two forms of contact that we can imagine, okay? There's no other form of interaction that we can even imagine. And particles and waves are one-way type mechanisms, okay? They can only push. Particles come out and move outwards. The stone leaves your hand and goes and breaks the window. Okay, so it goes forward only outside your hand, or forward from your hand, right? Waves always travel in one direction. You will see them always being illustrated, put in motion. They're always in one direction. And so both of them travel only one way. And so, those were the possibilities we had until today. We're offering something different. We're saying, we're proposing a mediator that can do both push and pull. Okay? Push gravity cannot be rationally justified. It's at odds with what everybody experiences. And here, I can, let me take this out for a second here. Imagine you got your hand stretched out, your arm stretched out, okay? And just hold them there for a little while. 10 minutes, 20 minutes, 30 minutes, whatever. And you will note that nothing is pushing on your arms downwards. Your arms are being pulled from below, from the earth. The earth is pulling your arms down. You don't feel any birds sitting on your shoulder. The pull is from the inside, okay, from the bottom. And here you see it also with magnets, okay? It's similar issue, do this at home, always in front of a trained mathematical physicist. You take this and you can see that, they're the two magnets, right? I've got two little magnets there, and they're being pulled from the inside. Nothing is pushing from the outside. I can hold them in my hand. I don't feel anything pushing on my hands. The pull is from the inside, okay? And same with gravity. Gravity and magnetism are pull forces. And so we got to figure out, how Mother Nature does this pull. And the first problem we find is that in the last 10,000 years, no one has come up with pull. And the reason is very simple. It's because, there's nothing that we can see or touch on the inside. I don't see anything that's pulling on my hand. And so people simply assume that everything was a push type of force, when it ain't. This is a pull type of force. But if it's pull, people say, well, how can you pull with nothing? That was really what went through their head. That's why they never figured this out. Okay, but let me continue here. If an atom attracts another, first, gravity must be mediated by an object. Okay, you have to have a physical object. Otherwise, you're doing black magic, or what mathematical physicists know as, or label as, action at a distance. Okay? Action at a distance is the scientific, the mathematical physics version, right, of black magic and witchcraft. They're saying that this affects that by remote control. There's nothing in between. And yeah, that's only in mathematical physics. Mother Nature does not work with, with black magic. And then if an atom attracts another, there must be an invisible, intangible entity. It's got to be invisible and intangible, okay? Because that's our experience. That is mediating a transaction, okay? It must also be an elongated agent. It's got to be like a wire, a string, a rope, something elongated, right? That stretches from one object to another. And so this is the architecture that you have to imagine for whatever mediates gravity. And what we're proposing is this DNA-like helical pair of threads that can do both gravity and light. Okay, so that's the introduction there. And so a lot of people don't like this. They criticize it for several reasons. I'm going to go through the reasons why they criticize it. But let's first find out what's out there. But even mathematical physics, what do they say about this? Here's the AI, the bots. Okay, let's consult them. Let's see what they have to say. Those are obviously programmed by the mathematicians. Okay, so here it is. Gravity is a pull force. It's a force of attraction. It pulls things together. That's the worldly wisdom among mathematical physicists. We agree with them. We make the same assumption. We're going to say that it's going to be mediated by something that's between two objects, not from outside of them pushing them in, but between them, pulling them towards each other. That's what we're saying is gravity. And the funny part is when you get to the bottom there, it says non-contact. Non-contact means action at a distance. There's no contact. They can't see anything. There's no force that they can see or measure or touch. And so they say there's nothing there. It's a non-contact force. And that's when they introduce words such as energy and field and mass. And that's great part of the problem. They introduce concepts and they're going to use them as objects. And that's where the problem starts, okay? Because now these people are trying to get away with murder. They're going to substitute objects with concepts. And that's been really the headache of mathematical physics for all these years. They cannot explain gravity or light for that matter, but gravity specifically, they can't explain magnetism either. Why? Because they're going to be using concepts, mathematical concepts, and they're going to do their physical interpretation with a concept. That's the problem. Okay, so here we have another testimony. I usually bring it up, and I think it's a very good testimony. It comes from Richard Muller, University of Berkeley, and he says the following. He says, if you have the Earth, there's a big mass here, and you have you with your little mass here. Every atom on the Earth is pulling on every atom of you. Okay, every atom on Earth, just every single atom on Earth is pulling on every single atom of you. You're also pulling on it. So we have one atom in your body. It's pulling on one atom of the Earth, and that atom of the Earth is pulling on one atom of you. In other words, let's say it differently. We're saying that one atom of you is being pulled by every atom on the Earth, and all the atoms of you are pulled by any, right, atom that belongs to the Earth. Okay, so it says there, you're pulling on atoms right now on the other side of the Earth. And he says the amazing thing about gravity is that it goes right through things. Well, obviously, if we're going to try to put an object that can simulate all of what he said there, a mouthful, an important mouthful, by the way, we have to put it some kind of elongated object. We have to somehow physically bind one atom of you with every atom on Earth, and any atom on Earth with every atom of you. Okay? Think about that. Every atom of you is connected to every atom of the Earth. Every atom of the Earth is connected to every atom of you. That's what he's saying. Okay? Now, you can't do that with general relativity's warp time. You can't do that with quantum mechanics, graviton, that delivers negative momentum. No, you can only do it from a physical point of view. You can only use some kind of string, rope, wire, cable, fiber, hair, whatever you want to call it. But it's got to be an elongated object that binds any two atoms. That's the specification. That's what you have to come up with. So I don't care what you come up with, but it's got to meet that specification. Okay, that's the important part. Okay, so what does general relativity and quantum mechanics say? Well, here it is. This is general relativity at the top. Gravity is most accurately described by the general theory of relativity proposed by Einstein, right? Describes gravity not as a force, but as what? A curvature of space-time. So we're curving time here, okay? That's what they're saying. We're going to curve time, whatever that means. How can you curve time? And they illustrate it. They show the sun weighing down this fishnet, this canvas, this trampoline, and because it pushes the space-time canvas downwards, right, we have the Earth rolling around in circles around the sun. That's the reason that they give for why the Earth doesn't leave the solar system. That's the GR version, the general relativity version. How about the quantum version? Well, the QM version goes like this. It is speculated that gravity is caused by what? Exchanging particles called gravitons. So we're exchanging particles. I throw stones at you, you throw stones at me, and somehow we attract each other. That's what they're saying. In fact, the fellow continues there. This is the stack exchange, right? Think of it like the way you would play catch with your friends. Well, there, when I play catch with my friends, I throw the ball, it pushes the catcher away. It doesn't bring them towards me. Imagine if the pitcher threw the ball and drew the catcher to the mound. Okay, I don't think that happens. I've never seen it happen. I want to see anyone try that, okay, and see if they can obtain that kind of result. Okay? You throw the ball and the catcher comes towards you, to the pitcher, to the mound. Yeah, sure. Okay, so what do people say? Well, I had a couple of visitors. They talk about that. Here's one of them. This is what he says, gravity is a part of the disturbance. It is the return vector. It's a vector. That doesn't sound like a physical object. Sounds like a concept to me, okay? So he's probably describing, certainly not explaining the cause of gravity. Nothing is pushing and pulling. So they do it with nothing. They do the push and pull with nothing. In fact, they're, stating it right there in front of your eyes, saying just like he thinks it, that there's nothing there. Why? Because he can't see or touch anything, so he assumes that there's nothing. Nothing, no things are pulling on the other things as gravity. Something invisible and non-spatial is disturbed. He's talking about what is being disturbed and not the mediator that is disturbing that something. Okay? And non-spatial is disturbed, and that disturbance is manifest as force. So he's talking about, he's giving us a description. He's saying it happens. We see something moving, and he describes it as some kind of vector. That's not an explanation. Again, and these people don't understand the difference between a description and an explanation. There it is. Explanation, you have to give me the cause. Saying a vector is a description, it's not a cause. Okay? And he is putting a concept, and he's treating it like a physical object in the back of his mind, because he's saying it's a vector. Yeah, but a vector is not a thing. It's a concept. It's a mathematical concept, really, the way it's used today. And you can't pull with a vector, or push for that matter, right? And the return vector is what we call gravity. Gravity is a pull force, is a logical fallacy. Okay. So this fellow doesn't believe in pull. He doesn't use that as a mechanism, right? Another fellow, he does something similar, but he's got a little different angle. He says the following. He says, you keep mentioning the physicist of yours, referring to Richard Muller, that said that every atom pulls on every atom of the earth, etc., right? Atoms on the other side of the earth pulling on every atom in your body is ridiculous. Okay? It's not only irrational, it's ridiculous. It's purely conceptual, will never be proven to be true. Yeah, we don't prove in science. In science, we explain so that you understand. Okay? Hopefully, you're still listening to me, hearing me. I hope the choppiness of my images doesn't affect the class today, the lecture today. Anyway, it says gravity diminishes as you go deeper into the earth. Yes. Okay, that doesn't rule out what he's saying here, that there's no pull force. And I'll show that in a second. As you move deeper, only the mass inside your radius contributes to the gravitational pull. And he talks about pull at the end, right? Okay, but he's right. Let's show this. Let me show it in a graph so that we understand what he's saying here. And this is it. Here's the journey to the center of the Earth, right? You're falling through a hole that we've dug all the way to the center, okay? And you can see there's different distances between you when you started to where you are close to the end. Let's show the different distances and what's going on according to the rope model, at least, right? Because he's saying there's no pull, okay? You can see the ropes tied to every atom of that fellow who's falling. Maybe that's you, right? And I'm only showing all the ropes, or many of the ropes from the Earth, tied to one atom in his toe. That's all I'm showing there, okay? And but you can imagine tons of ropes doing the same thing, you know, being connected to every atom in his body. And as he falls, you can see there are more and more ropes pulling from above him than from below. In other words, when he started his journey, all the ropes on the Earth were below him. And so he's attracted by, or pulled, you can say, by every rope that's below him. But as he falls, you see that he has ropes now behind him, above him, pulling him upwards. So by the time he lands, you know, in the center of the Earth, he probably can, you know, is at zero speed. He probably doesn't hurt himself, okay? So what he said does not eliminate pull, what this fellow said, right? It doesn't eliminate pull. He just said it can't be pull, and he doesn't explain why it can't be pull. There I'm showing that it can be pull. Okay? So yeah, and we're saying again, let's make sure we understand. We're not saying gravity is a pull force, okay? Again, pull is a force, and we're saying that every rope is simply under tension, and tension is not pull or push. It's not a force. Force, the way the word force is defined, someone wins the tug of war. Between two atoms, no one wins the tug of war, okay? The rope is simply under tension. It's a tie game. The tug of war is a tie game, always, under tension, okay? Tension is something different than pull. Unlike in the religion of mathematics, they think tension is some kind of pull force. It's not a force at all. Okay, it's again, by definition, no one wins the tug of war. But again, the more ropes that you have coming out, what's happening, they're spreading out. They're not on the same axis anymore. When you're at infinity, to use that term, right? All the ropes come together. It's a single coaxial. That's why gravity is weak. As you fall, the ropes fan out. Now you have this acceleration of gravity because more and more ropes are acting independently. That's the theory. Okay? Do you believe it? We don't care if you do or not. In science, we don't care what you believe. Belief belongs to religion. Here we only explain so that you understand.